when you look at footage or photographs of astronauts in space, it doesn't look like there's any gravity at work here. Everything is not falling down in one direction. In fact, it's not even clear what up or down is. Everything just floats around. If I were to push off of this wall, I would just float in that direction. So it doesn't look like there's this overarching influence like gravity that's trying to pull everything down. But the question is that these astronauts are still not too far away from a supermassive body. In fact, the space shuttle gets up only a couple of hundred miles above the surface of the Earth. So the space shuttle, if I were to draw it to scale, would probably be right about there. And we know that the force of gravity between two objects is equal to big G, the gravitational constant, times the mass of the first object times the mass of the second object over the distance between the two objects squared. And if the space shuttle is right here, only a few hundred miles above the surface of the Earth, this r isn't that different. It's a little bit further than if you were at the surface of the Earth. Remember that r is measured from wherever you are to the center, from the center of the Earth, or really the center of the object to the center of the Earth. The center of the Earth represents most of the distance here. So if I'm at the surface of the Earth, or if I'm just a few hundred miles above the surface of the Earth, it's not going to change r that dramatically, especially in terms of percentage. So when you look at it this way, it seems pretty clear that the force of gravity for someone who is in space only a few hundred miles above the Earth should not be that different than the force of gravity for someone who is on the surface of the Earth. So my question to you is, what gives? If there should be gravity in space, how come we see all of these pictures of people floating around like this? And the answer is that there is gravity in space, and that these people actually are falling. They're just moving fast enough relative to the Earth that they keep missing it. And let me show you what I'm talking about there. So if I were to let's say I'm sitting here in Africa, and I were to shoot something, or maybe I have a really good slingshot, and I were to sling something super fast at maybe a 45-degree angle, it might take off a little bit and then eventually hit another point. And this would actually already be a super duper slingshot. I just made it travel a couple of thousand miles, or at least over 1,000 miles. If I make it go a little bit faster, if I put a little bit more force on, if I just propel the projectile a little bit faster, it might go a little bit further, but it'll eventually fall back to the Earth. Let's try to propel it a little bit faster than that. Then it'll still fall to the Earth. Let's propel it even faster than that. Well, then it's still eventually going to fall to the Earth. I think you might see where this is going. Let's go even faster than that. So if we go even faster than that, eventually it'll fall to the Earth. Even faster than that. So if you were to throw an object even faster than that, it would then go really far and then fall to the Earth. But I think you see what's happening. Every time you go faster and faster, you throw this projectile faster and faster, it gets further and further up to some velocity that you release this projectile. And every time, and whenever it's trying to fall to the Earth, it's going so fast that it keeps missing the Earth. So it'll keep going round and round and round the Earth. And a projectile like that would essentially be in orbit. So what's happening is, if there was no gravity for that projectile, if there was no gravity, the projectile would just go straight away into space. But because there's gravity, it's constantly pulling it towards the center of the Earth, or the center of that projectile and the center of the Earth are being pulled towards each other, I guess is a better way to think about it. The force of gravity is doing that. And so it's curving its path. And if it's going fast enough, if the projectile or whatever object we're talking about is going fast enough, it'll just keep going round and round the Earth. And since there is almost, pretty much for most purposes, no air at, if you go high enough, especially the altitude that the space shuttle is, no noticeable drag, this thing can just keep on going for a substantial amount of time. Although there is just a little bit of drag, and that's why over time you do have satellites slow down, because there is just a little bit of air resistance. So the answer to this conundrum is that there actually is gravity. It's not a gravity-free environment. It's just that the astronauts and the space shuttle and everything else that's in the space shuttle, it's all falling, but it's moving fast enough that it never hits the Earth. It keeps missing the Earth. It keeps going round and round and round, but it is completely under the influence of gravity. If they were to just slow themselves down, if they were to just brake relative to the Earth, and if they were to just, they put their brakes on right over there, they would all just plummet to the Earth. So there's nothing special about going 300 or 400 miles up into space that all of a sudden gravity disappears. The influence of gravity, actually, on some level, it just keeps going. You can't, it might become unnoticeably small at some point. But definitely, if you're only a couple of 100 miles up in the air, there is definitely gravity there. It's just they're in orbit. They're going fast enough. So if they just keep falling, they're never going to hit the Earth. And if you want to simulate gravity, and this is actually how NASA does simulate gravity, is that they will put people in a plane, and they call it the vomit rocket, because it's known to make people sick. And they'll make them go in a projectile motion. So if this is the ground, in a projectile path, or in a parabolic path, I should say. So the plane will take off, and it will do a path exactly the same as something in free fall, or in a parabolic path. And so anyone who's sitting in that plane will experience free fall. So if you've ever, right when you jump off of if you've ever bungee jumped or skydived, or even the feeling when a roller coaster is going right over the top and it's just pulling you down and your stomach feels a little ill, that feeling of free fall, that's the exact same feeling that these astronauts feel, because they're in a constant state of free fall. But that is an indistinguishable feeling from if you were just in deep space and you weren't anywhere close any noticeable mass. That is an identical feeling that you would feel to having no gravitational force around you. So hopefully that clarifies things a little bit. To someone who's just sitting in the space shuttle, and if they had no windows, there's no way of them knowing whether they are close to a massive object and they're just in free fall around it, they're in orbit, or whether they're just completely far away from any massive object and they really are in a state of, or in a place where there's very little gravity.